In this video, we're going to talk about two angle theorems that relate specifically to triangles. The first one is called the Triangle Sum Theorem, or the Triangle Angle Sum Theorem. And what the Triangle Angle Sum Theorem states is that the measures of all the angles in a triangle adds up to be 180 degrees. So this angle plus this angle plus this angle equals 180. The second one that we're going to talk about is the exterior angle theorem. And first, what's an exterior angle? You extend any one side of a triangle, so we're going to take this side and extend it, and we're going to create an exterior angle right here. And so that exterior angle is always equal to the sum of the two non-adjacent, so the two angles here that are not next to angle 1. That's what angle 1 adds up to, the measure of angle 2 plus the measure of angle 3. I also know that if I tossed in just another random angles, call this angle 4. Let's take a look at some interesting things that we already know. So across the bottom of the screen here, we have a couple of items to pay attention to. First, we have the idea that the measure of angle 1 and 4 here, by linear pair postulate, they add up to be 180 degrees. And we also set up here, the triangle sum theorem, that if I take all three angles inside the triangle, they also add up to 180 degrees. So 180 is equal to this sum, and 180 is equal to that sum. So it should suffice that the two sums themselves are equal. So we can just take 180 right out of the picture. And when you say that this left side here is equal to the right side, what do you notice? The measure of angle 4 is on both sides. So if you remove, algebraically, subtract angle 4 from both sides, what do you have? The measure of angle 1 equals the measure of angle 2 plus 3, which is what we're saying in the exterior angle theorem. So it's just sort of a little informal proof of why that works. Now let's put it into action. Before we jump straight into it, just make sure that these two items are in your notes, and then we want to sort of take a little trip down memory lane and make sure we understand the relationships. All linear pairs are supplementary. All vertical angles are congruent. When the lines are parallel, corresponding angles are congruent, so are alternate interior and alternate exterior. And our consecutive interior are the other supplementary pieces. So now we have the triangle sum theorem, the exterior angle theorem, and then our 6 players that we already had with us to begin with. Our first example here looks like it's going to be the triangle sum theorem, that all the angles, right, the sum is equal to 180 degrees. So I know that I have 24 and 37, and an angle that I don't know equals 180. Combine your like terms, subtract from 180, and get your value for x. You should arrive that the measure of angle 1 is 119 degrees. Okay, moving on. Our next question looks like it involves the exterior angle theorem. Mainly because I see this exterior angle out here, and I see two interior angles. So if I'm looking for the measure of angle 1, that's going to be the sum of the two non-adjacent inside. So simple enough, just set my exterior angle equal to the sum of the two non-adjacent interior angles, which should add up to be 128 degrees. Same goes for the process of my last question here, but the exterior angle is given. What I'm missing is one of the interior ones. So let's see how this setup differs. So the setup here is going to say that our exterior angle is equal to the sum of the two non-adjacent interior angles. So 104, the exterior angle, is equal to the sum of the two angles that are on the inside. But I don't know one of those. So really what I'm writing is 104 equals 79 plus x. And then I just subtract 79 from both sides to get a measure of 25 degrees for angle 1. And you could back check that by adding 79 plus 25 to make sure you get 104, which, of course, we're all set. Let's move on. Now things get a little bit more complicated, and you have to start looking at the different pieces in the picture. So on number 5, if you look, you have a triangle on the inside. Let's call that the red triangle. And then on the outside, you have this big triangle. Let's call that the blue triangle. And then you also have a third triangle right here on the inside on the right, the green triangle. So let's take this one step at a time. The first one, for the red triangle, I have two of the three angles. I have the 90-degree angle here, so that's 90 degrees, and I have the 43-degree angle, and then I have angle 1, which I don't know, so I'll call that x. I know that's equal to 180. So I can find out the value of that angle measure, the measure of angle 1. So I'm going to combine my like terms and subtract from 180, and I should get that x is equal to 47 degrees. So I put 47 degrees here. Now we move on. Now I said that angle 1 was worth 47 degrees, and I want to think about the blue triangle. Well, the blue triangle is this big angle right here. And so that's going to be 47 plus 12. And of course we got the 90-degree angle up here. So the three angles on the blue triangle would be 90 degrees, that's one of the angles, plus the 47 plus the 12, that equals one angle, plus angle 3, I don't know, that all adds up to be 180 degrees. So when I add that all up, I get the 47 and the 12. Keep in mind that that's going to be 59, and that's going to be the 90, plus, I don't know, I'll call this y for now, is 180, and when I add the 90 and the 59 together and subtract from 180, I'm going to get the measure of angle 3, and that's going to be 31 degrees. Now for angle 2, I could look at it one of two ways. I could take the 12 degrees from the green triangle, add that to the 31 degrees I just found. Let's call angle 2 the letter Z. I could add that all up, subtract from 180, and I'll get the measure of angle 2, which happens to be 137 degrees. That being said, I could also look at the linear pair that's right here and just take 180, subtract 43 from that, and also get 137 as a linear pair. Either way, I have all of my angles. So again, I need to take into use my exterior angle theorem. I need to take into consideration my linear pairs and vertical angles, those 6 pairs, special angle pairs that we have, or my triangle sum theorem. So exterior angle theorem, triangle sum theorem, or the 6 angle pairs that we had. You are to complete number 4 on your own. So press pause and complete number 4 on your own now, then move on. So now we just continue on with, these busier pictures. What's the first thing I see here? I see that I got a pair of vertical angles. So if this is 61 degrees, then so is angle 2. So just by looking and being aware of what's going on, identify a vertical angle pair, I've already identified one of my missing angles. Now that I know that this is 61 degrees and this is 90 degrees, 61 plus 90 plus the measure of angle 3 is equal to 180. So by adding up 61 and 90 and subtracting from 180, I should get that the measure of angle 3 is equal to 29 degrees. I come up at the top, I got 61 and 68, so 61 plus 68 plus the measure of angle 1 is equal to 180. Why don't you wrap that up and get number 1 on your own. Our next question involves a little bit of given information up here. And so what do they tell us? They tell us that BC bisects ACD. So bisect means to cut in half. And who did it cut in half? BC, this segment right here, bisected angle ACD. So this angle right here was cut in half. And that angle was originally 90 degrees. So the measure of angle 2 equals the measure of angle 3. If the two of them together were 90 degrees, then I guess each of them individually is half of 90, which is, of course, 45 degrees. So we'll put 45 here and 45 here. Now, if I know that angle 3 is 45 degrees, I know that the other angle in this blue triangle right here, I know it's a little messy. Clean that up for a second. So I have angle 3 is 45 degrees. I know that this is 83 degrees, and I have myself a triangle right here. I could certainly get 84 using the Triangle Sum Theorem. Also, up on the green triangle up here, I got 48 degrees. We said that 2 is 45, so we have 2 of the 3 angles in that triangle, so I can get the measure of angle 1. So go ahead and wrap that one up on your own, press pause, and move on when you're ready. On numbers 8 and 9, I just want to guide your thought process, and I want to do it all for you. First, let's take a look at the triangle on the right. I know that I have a 54-degree angle, and then I've been given that that's a 90-degree angle. So using the Triangle Sum Theorem, I can find angle 3. On the left side, we'll call this the blue triangle, I know that I have 2 of the 3 angles, so using the Triangle Sum Theorem, I can find angle 1. So angle 1 and angle 3 are pretty simple. Then I want to just kind of draw the picture of what's going on here. I got angle 1's right here and angle 2's right here. And it's been given on the other side that this is 90 degrees, which makes these guys complementary, which means they add up to 90 degrees. Well, I think you should have already answered angle 1 by this point, getting angle 2 as a cinch. Now let's move over to number 9. The thing I want to draw your attention to on number 9 is that line L and M are parallel, which would make this a transversal, which would make 49 degrees and angle 4 alternate interior angles. So you should be able to answer angle 4 right off the bat. Once you get angle 4, you got your three angles inside of a triangle here. Triangle Sum Theorem should get us that 73, and I have angle 4 at this moment. Now I can get angle 2. So we have 2 of the 5 angles at this point. Now I come over and I look at this transversal right here, and I notice that 1 and 73 are also alternate interior angles. So I should be able to answer angle 1 pretty quickly. When I look at angle 3, I see that angle 3 forms a linear pair, so that's pretty easy to answer. And along the same line of thought, angle 4 and 5 are a linear pair, and we should have already identified what angle 4 is, so we should be able to use that supplementary relationship to answer angle 5. And that's how we answer 5 of the missing angles really quickly. What I'd like for you to do is to try to answer as many of the angles here that you can. Don't answer it if you don't know what it is, but try to do your best. Keep in mind that these 2 lines here are parallel, and how do I know? Because I see those extra arrows right there. So I got a transversal and parallel lines, and then I got a transversal and parallel lines, and also transversal and transversal. Inside you got linear pairs and vertical angles, so do your best there. Over here on the left side you got triangles and triangles and triangles. There are linear pairs in here. There's 90-degree angles in here. There's complementary angles over here. So do the best that you can and trying to work your way around a little bit at a time. Answer as many as you can and answer out of order. Don't necessarily answer 1 first. It's not necessary. You might see angle 6 first. Answer that first. Do the best you can on 10 and 11. So you had to know that algebra was coming your way eventually. And again, this is the Triangle Sum Theorem. How do I know? Because we're talking about 3 of the interior angles of a triangle. And what do I know? They add up to be 180. So how do we express that? The measure of angle D plus the measure of angle E plus the measure of angle F equals 180. Now let's substitute who they are. So instead of angle D, I'm going to write 5x minus 2 plus the measure of angle E is 9x plus 3, and the measure of angle F is 11x minus 21, and that's all equal to 180. Now we're going to combine like terms and solve. Press pause. You wrap this one up and get a value for x. After combining like terms, you should get 25x minus 20 equals 180. So on and so forth, you get an x of 8. So I put that here. Now they want the measure of angle D, E, and F. So I'm going to substitute 8 in for x on all 3 angles and get the final measurements. So for example, 5 times 8 minus 2 is the measure of angle D. So the measure of angle D is equal to 38 degrees. So I've placed that answer right here. You complete these two and then move on. After you've substituted 8 into this algebraic expression and this expression, put in the correct values for E and F, and then add them all up and make sure that it actually does equal to 180. Then move on. This has to do with the exterior angle theorem. And what that theorem says is that this exterior angle, right, 9x minus 8, is equal to the sum of the two non-adjacent interior angles, which is 5x minus 27 and 7x minus 32. Now this one's a little bit more complicated on the algebra scene. I got my 9x minus 8 on the left side, but then I'm going to combine terms on the right side before I go using inverse operations. So I come up with 12x minus 59. Now I would like to move my 9x to the right side, and at the same time I'm going to add the 59 to both sides because I'm a little tight for space. And when I do that, I'm going to end up with 3x equals 51, divide by 3, divide by 3, x is equal to 17. So that's my value for x. Now we go get all the values of our angles. Now take notice, all of the angles are all named using 3 letters. So where is angle JKL? JKL is my 7x minus 32. So when I put 17 in for the x, that first angle is going to be 87 degrees. KJL, my KJL is going to start at K to J to L. That's this 5x minus 27. My KJ or KLJ is going to be KLJ. That's right here. I don't have a value for that, so I'm just going to hold off for an expression. And then my last one, KLM. KLM is this exterior angle out here. So that's the exterior guy, right? That one's the exterior angle. But once I have that, if I subtract that, it's got a linear pair relationship over here. There's a linear pair relationship right here. And so my underlined green one that I had before, it's going to be 180 minus this guy. And that's how I'll find that inside angle. Remember that KLJ doesn't have an actual algebraic expression, so I'm just going to have to subtract KLM from 180 to get it. So you wrap that one up, press pause, and finish. You're going to have to flip the page in your notes and find the more practice section, and that's where you'll find number 1 will match up. And so I just want to set this up for you, right? This is the Triangle Sum Theorem, and on the right side this is also the Triangle Sum Theorem. And again, how do I know? Because these are all interior angles here, and these are all interior angles here. So this is 90 plus 5x minus 2 plus 3x plus 4 equals 180. And why? Because that's what the Triangle Sum Theorem says, that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So this is just a matter of substituting and solve. So get a value of x, and then you're done. How do I know? That's all the question asked for, was the value of x. On number 2, we have something similar. So go ahead and solve number 1, because I'm going to erase this in a second. Now just keep in mind, you should have an x equals for this answer and an x equals for this answer when you're done. Again, Triangle Sum Theorem says for this triangle that x plus 2 plus 9x minus 8 plus x plus 10, right? All the interior angles of a triangle add up to 180. Solve for x and then move on. Press pause now. In number 8, it says that there's triangle PQR, but there is no triangle. So what we're going to have to do here is just create our own triangle. Now I've flipped back to where we were in our notes prior to going to question number 1 and 2. Sorry for making you go back and forth. It doesn't matter where you put PQR, you can put it anywhere. And then, now that I have that there, it says angle P is x minus 12. So that's right here. And then angle Q is 5x minus 27. So that's right here. And angle R is 2x plus 3. That's right there. So this is really no different than the other questions. We're at a triangle sum theorem type question. Again, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So we have x minus 12 plus 5x minus 27 plus 2x plus 3 equals 180. Solve for x, put that there, substitute into each algebraic expression the value of x, and get the three angles that are missing. And keep in mind that all three of those should add up to 180. That's how you'll know that all of your algebra went well. Go ahead, press pause, and solve that one. This last question is a little bit tricky. All I have to do is find the values of x and y. And so I see that I got the 6x minus 2 up here. So I know that 6x minus 2 plus 72 plus something equals 180. And I see this 11x minus 9 is right here. And I know that these are vertical angles. So if this is 11x minus 9, this is 11x minus 9 too. So 11x minus 9 is my third angle in this upper triangle here. Once I solve for x, I can get an actual value for this angle. And once I know that number, I can take that number, whatever it is, and I'm going to take that number, I'm going to add it to 30 and add that to 5y minus 8, and that's also going to equal 180 because that's the three interior angles of this triangle, and then I'll have an answer for y. So solve for x first, substitute that into this expression to get the value of that angle, and use that to place right there and solve for y, and then you're done. And that's a wrap. Good luck. Feel free to ask me any questions you have.